Hey guys, we're going to be doing Chapter 5, Lesson 2, which is solving systems of equations by substitution. And at this point, we have solved systems of equations by graphing, but I know not everyone likes to graph, myself included, and sometimes graphing just isn't the best way to solve. So there's other ways to do systems of equations, and one of those ways is by substitution. So that's what we're going to talk about today. And before we solve and start getting into the problems, we should talk about when it's most appropriate to use the substitution method. And when you see a system of equation and one of the variables in either of the equations has a 1 in front of it, which when we're looking at it, it has nothing in front of it, but really right here has a 1. If any time this is present, substitution is going to be a good choice, and you'll see why in a second. So I'm going to actually rewrite these two equations down here, and then we're going to get to solving using substitution. And the reason it's called substitution is because you're literally going to substitute one equation into the other. I'd like you to notice that this says y equals 4x minus 1. And this equation has a y in it. Well, if we know that y equals this, why can't we just take this and substitute it in for y? We can, and that's what you need to do to solve using substitution. So what this is now going to look like is 2x So I rewrote it 2x plus 2, but instead of y, since I know that y equals 4x minus 1, I'm going to plug that in right here into the equation. So instead of y, I'm going to use 4x minus 1 equals 3. So take a look at what we just did. Pretty simple. We have an equation that's telling us that y equals 4x minus 1. I know what y equals, even though it looks kind of funky, it's an equation. But because I know what it equals, I can plug it in for y in the other equation. And now look, I have x and x. I have one variable. I know how to solve like that. We've already done these type of equations. I'm going to solve, and I'm ultimately going to find out what x equals. So let's do that. 2x plus 2, and then in parentheses 4x minus 1. Very important, you should always use parentheses when you're substituting, because you're substituting that whole thing, 4x minus 1, not just the 4x, just not the minus 1. So the whole thing surrounded by parentheses to set it apart. So I'm going to distribute first. So this is going to be 2x plus 2 times 4x is 8x, and 2 times minus 1 is minus 2 equals 3. I'm going to combine like terms. So let's get some more room. This is going to be 10x, because 2x plus 8x is 10x, minus 2 equals 3. Add 2 to both sides. 10x equals 5. And then I'm going to divide by 10. Divide by 10. So I've got x equals 5 over 10, which is really just a half. Some of you might have a decimal 0.5. That's fine as well. I'm going to leave it as a fraction. So now I know what x equals, so I can use this information to help me find out what y equals. And the way I can do that is I can take my x equals a half, and I can plug it in to any of my original equations, either this one or this one. And then when I plug that in, I'll have what y equals. So I'm going to use y equals 4x minus 1. And I'm going to substitute in 1/2 for x. Now I've got one variable, and I can solve very quickly. 4 times 1/2 is 2. So I've got y equals 1. Now I've solved the system. I know what x equals. I know what y equals. And just like in the ones where we graphed, what does this really mean? This is where these two lines would intersect at the point 1/2, 1. So the solution to this system is 1/2, 1. And as always, you can check by taking these and plugging them into either one of the equations or both of the equations. I know that this is the right answer, so I'm not going to do that. And I know that you know how to check if you need to. But that's all there is. And why is it called the substitution method? Because you're substituting a ton of stuff through the course of this. Let's look at one more example that's like this. We've got y equals x plus 1 as one of the equations and 2x plus y. I have 1 in front of this y, so I can use this to substitute right into here. So I'm going to rewrite this as 2x plus, and I'm going to use x plus 1 minus 2. Really, I can combine like terms. 2x plus x is 3x plus 1. Wow, I wrote this incorrectly. This should be equals negative 2. Equals negative 2. So minus 1, 3x equals negative 3. And then divide by 3, divide by 3. X equals negative 1. Now that I know what x equals, I can just plug that into one of the equations. This one looks easier, so I'm just going to use that. Y equals x plus 1. X is negative 1. And negative 1 plus 1 is 0, so y equals 0. So the solution to this system is negative 1, 0. And I know this one's right. I'm not going to check it, but you know how to check if you need to, which you should do real quick. It only takes, I don't know, 20 seconds to check yourself and make sure that your solution to the system is right. And that's all there really is to substitution. There are problems that can be a little more challenging, like this. So I've got negative 9x plus 5y equals negative 1, and I've got negative 3x plus y equals 4. So to solve this kind of one, I've got to ask myself first, can I use substitution? And the answer is yes. Why? Because this variable, this y, has a 1 in front of it. Now the issue is this y is not by itself. It's on the same side as the 3x, or the negative 3x. So the only extra step you have in this scenario is you need to, and I'm going to rewrite this, negative 3x plus y. You need to rearrange this equation so that the y is by itself. And you know how to do that. You might just need to see it once to get the hang of it. But how can I get rid of this negative 3x and not get rid of it? How can I move it? Well, I can do its inverse operation. So what's the opposite of minus 3x? Plus 3x. So that effectively gets rid of it here. But whatever you do to one side, you do to the other. So now I've got y equals 4 plus 3x. And now I've got y by itself. I didn't change the equation, I just rearranged it. So now I've got y, and I can plug it into this first equation for y, substitute it, and I can solve. So let's do that. I'm gonna negative 9x plus 5y equals negative 1, except I'm going to substitute for y. 4 plus 3x equals negative 1. And now I'm just going to solve. If you want to pause the video and try to do it yourself and see if you end up at the same spot, that's great, but here we go. First step is obviously going to be to distribute. Okay, and I'm going to combine like terms. Negative 9x plus 15x is 6x plus 20. Okay, and I'm going to subtract 20 from both sides. And now I'm going to divide 6 from both sides, and don't leave it as a fraction. Don't leave it as negative 20 over 6. If you do your division or just use a calculator, you'll find out that this is going to be negative 3.5, negative 3.5. So there's x, and now how can I find y? Well, I can substitute x back into one of the equations. I'm just going to use this first one, so the second one, negative 3x plus y equals 4. We know what x equals, we just solved for it, so x equals negative 3.5. It's negative. plus y equals 4. So negative 3 times negative 3.5 is 10.5 plus y equals 4. Subtract 10.5 from both sides, and you're going to get y equals negative 6.5. And that's all there is to it. Always double check, but I know that those answers are right, so if you got them, the solution to this system is negative 3.5, negative 6.5, and that's it. And one more of these. You can pause and try by yourself, which I would recommend. It's a good challenge, but if you're a little stuck, you can watch one more. I know that I can use substitution because there's a 1 in front of this variable, which means I can rearrange this so that I've got y equals something. And I'm just going to say this real quick. If there was like a 2 here, 2y, if I rearrange this, I would still have a 2, and I would have 2y equals, and then I couldn't substitute it in for y. I need just y by itself, so it's got to have a 1 in front of it, or nothing. So if I rearrange that equation, I would need to add 2x to get rid of it here, and then add 2x here. That's an x. Y equals 3 plus 2x. Now I can substitute this into here. So 3x minus 2y equals 0. And I'm substituting in for y. And just like all the other ones I've done so far, I'm going to solve. And if you solve this correctly and got all the way to the end, hopefully you got x equals negative 6. And then to solve for y, I'm going to plug that back into one of the equations. I'm just going to use this one because it's right here. So 3x minus 2y equals 0. Then x equals negative 6. So 3 times negative 6 minus 2y equals 0. So negative 18 minus 2y equals 0, plus 18 cancels out here. Divide by negative 2, divide by negative 2, so y equals negative 9. So the solution to this system is negative 6, negative 9. There's your answer. And again, I can't stress this enough. I know that these answers are right because I picked the problems and I've done them already. But if you're solving these for the first time, please, please, please double check by taking your answer, so in this case negative 6, negative 9, plug both of those numbers into the equations and make sure that they equal what the equation says. It does not take long, and you don't even have to do it on paper if you don't want to. You can just do it just by using your calculator. But it just ensures that you got the right answer, and if you didn't, you can always go back and just check your work and maybe you made a little mistake. But there's the work, there's the problems, and now I'm just going to do one word problem so that you can see how a word problem looks, and then we'll call it quits. So this one is Elian's phone plan. It costs $40 per month plus 20 cents per text. Martin's phone plan costs $45 per month plus 10 cents per text. And I want to know how many texts will it take for their plans to cost the same per month? And then when you figure that out, what will the monthly cost be? Well, I know that for one of the plans, the cost, which I'm going to call y, is equal to $42 per month plus 20 cents per text. And I'm just going to define my variables over here so I know what they stand for. Okay. So that's for one of the plans. The other one, Martin's, he pays $45 per month but he pays less money per text. So how can I figure out when they're going to cost the same? Well, I need to figure out what the variables are equal to. So I know that y equals 42 plus 20 cents x. Well, I can use either of these. I'm going to choose this one. If this is what y equals, I'm going to substitute it in for y. So 42 plus now I've got one equation, and I've got one variable x, and I've got x, and that means I can solve it. That's solvable. You've done these before. What do I need to do? I got to get all my x's together, so I'm going to take these and move them over here through inverse operations. So now I've got 42 equals that. Okay, and this should be a plus. Made a little mistake, but good thing I caught it. Now I'm going to get rid of this 42 and bring it over here. So I've got 10 cents x equals 3. Need a little more room. And to finish this off, I'm going to divide both sides by the 10 cents that are in there. So divide 3 by 10 cents, and x equals 30. But remember what the question was. What will the number of texts be? Well, if x stands for text, at 30 texts, these plans will be equal. And it also wants to know what will the monthly cost be. Well, remember, y is the monthly cost. So I'm going to need to plug in x into one of the original equations. So I'm going to use the second one. It doesn't really matter. You'll get the same answer either way. I just picked this because I saw it first. So this was the original equation. I took x and I plugged in 30. So I've got y equals 45 plus 3, which means y is going to equal 48. So the solution is 30, 48. But let's make it make sense for the problem. The question was what number of texts? So at 30 texts, the plan will cost $48. Okay, so there's the solution to this system of equations. That's an example of a word problem. Usually I do a lot of word problems, but I'm just going to do one because they're all very similar in this section, and we're going to do a lot of them in class, and you've got one in your summary questions to try. So rewatch that if you need to. Here's your 2 summary questions. There's only 2. Please try them. Bring them to class. We'll go over them. If you have any questions, you can email me, and if you want to just send me your answers to check, you can always do that. But otherwise, this is solving systems of equations through substitution, and I'll see you tomorrow.